the fishery a fishery resource planner for the county, and her projects and programs to protect and enhance the river and its watershed. I mean, she really has focused on habitat for steelhead and coho. She's got a master's degree in conservation biology with a focus on stream and river ecosystems, which has been used throughout her entire career. Kristen is going to be talking about the historical structures, a study of historical structures and fish passage in the San Lorenzo River. So she might be getting a little bit more into those things like the dams and the other structures that have impacted the river. So we'll turn it over to Kristen now. Thanks for being here, Kristen.
Good morning. I'm really happy to be here. This is my first presentation post-retirement, and I'm really happy for the opportunity to share this other long-term study that is finally completed. So I'm going to talk about this report the study is called the Inventory of Historical Structures and Anadromous Fish Passage Conditions in the San Lorenzo River. And I'm going to start by making sure you guys understand what I mean by historical structures. And fortunately, the previous speakers have talked a little bit about anadromous fish passage, and I'll review that a little bit so you can understand the results of the study. So I was the project lead over the course of the study, and I was supported through the Water Resources Program with the County of Santa Cruz. But the county didn't do this project all on our own, of course. We had 4 primary study partners. We got a lot of technical support and assistance from the California Department of Fish and Wildlife, which I'll call CDFW, NOAA Fisheries, which is the federal agency, the Resource Conservation District of Santa Cruz County, which I'll call the RCD, and the Watershed Stewards Program, which supplied the young people that helped us with all the challenging field work. You know, well over 50 people contributed to this study, so I'm going to say we, because it was very much a group effort. And we got a lot of support from the property owners who own these historical structures, other local, state, and federal agencies that contributed information or guidance or feedback. So we had 3 study goals. The first is the inventory part. We wanted to locate, describe, and assess fish passage severity for historical, that's just short for old, human-built, structures within the San Lorenzo River. And most of these structures were flashboard dams, which I'll explain, but it also included road or bridge crossings and railroad piers. The second goal was to align the results of the study with the CDFW Passage Assessment Database. And this is a statewide database that keeps track of barriers for anadromous salmonids. And then the third goal was to provide information that contributes to the removal or modification of historical structures for steelhead, coho salmon, and Pacific lamprey fish passage. We really didn't want this report to be on a shelf. We wanted to be able to use it to support implementation. And this is really critical because if the organizations that have grant funding for fisheries restoration, they want to see that it's in context and that they understand what they're funding in the context of the watershed as a whole. So that was why it's important to put all this information together in a study. So the study is built on a series of 4 years of field surveys, 2006, 2014, 2020, and 2022. And we also use the results of a preliminary field survey that had been completed by CDFW. And this 2001 study actually helped contribute to the San Lorenzo Steelhead Enhancement Plan from 2004. So these kind of field seasons generated, of course, a lot of data, including that GPS location, the condition of the structures, passage severity, and then the county also developed a whole photo library so that we could see what these structures looked like at different flows. So there's two products to this study. One is the inventory report that the county put together, and I'll give you links to that at the end of the presentation. And then again, this other CDFW passage assessment database. So all the data is also available online through this BIOS map viewer. Okay, you've heard about these, you've even seen some of the same pictures. We have 3 anadromous fish species in the San Lorenzo River. We're talking about steelhead, which are listed as threatened under the Federal Endangered Species Act. And steelhead are found throughout the watershed. So they're using the whole main stem and the tributaries. They're really widespread throughout the watershed. Then we have coho salmon, which are listed as endangered under the Federal and State Endangered Species Acts. And they're infrequently in the San Lorenzo watershed, but the San Lorenzo is really important for their recovery. And more recently, there's more attention to Pacific lamprey, which is a really ancient fish, and it's now listed as a state species of special concern. So anadromous life history, it's a complex life history, but it basically means that adults swim from the ocean up fresh waters to spawn, which means reproduce, lay their eggs. Then the young hatch and rear in fresh water for different amounts of time, depending on the species. And then the juveniles migrate to the ocean to mature. And so what's important is that these fish species need both the ocean habitat and the freshwater habitat to complete their life history. And they need to migrate between these 2 different habitats, and they also need to move within the freshwater habitat. So for all 3 of these species, and that's in the white type, so for all 3 of these species, the adults need fish passage, or that ability to move up into the freshwater habitats. Adults need upstream fish passage to get to spawning areas, and then juveniles also need downstream fish passage to get out to the ocean. Now, steelhead some adults survive spawning, and so you also need to be able to get adult steelhead after they've spawned back downstream to the ocean. And coho salmon they die after reproduction, so not an issue for coho salmon. And then for both steelhead and coho salmon, then juveniles sometimes need to move upstream to either find better habitat or suitable habitat, maybe get out of the estuary to escape early winter storms. So you really need to understand that these fish need to move up and down the river. But we have these historical structures in the river. There are 24 of these structures that span the river that are impacting fish passage. So we decided on the term historical structure. That just means old. Most of these structures are 70 to 90 years old, and they're human built. And I just want to clarify now, there are other natural features in the river. A lot of you know that the gorge, there's steep boulder cascades, there's bedrock shelves, there's shallow riffles. There's other natural features in the river that affect fish passage. But this study was looking at human structures that are in the river that are obsolete and not really serving a function. Okay, we got a great introduction from Lisa Robinson about the cultural history of San Lorenzo, and that's why these structures are here, is that there was a history of swimming and boating on the San Lorenzo River. I have these 2 photos came from the San Lorenzo Valley Museum. The upper left is showing folks swimming at Ben Lomond you can see the dam on the right side of the photo. So by damming up the river, then you create these deeper areas that's more fun for swimming and boating. And then in the lower right, this is again that earlier Boulder Creek Dam. She showed the same picture, and you can see the boards. These are called flashboards, and basically the flashboards are damming the river to make it deeper for swimming and boating. This is what one of these structures looks like in a more modern sense. This is a photo from 2006, and this is a privately owned recreational flashboard dam with the flashboards installed in 2006. And if you can imagine being a fish trying to swim up or down the river when these flashboards are installed, it's pretty difficult. As Lisa mentioned, but these structures didn't have any fish ladders or any fish passage considerations. You know, it was seasonal, so generally people installed them on Memorial Day, and they pulled the flashboards at Labor Day. So it was a seasonal thing where there was they really impacted fish passage. Now, after steelhead and coho salmon were listed under the Federal Endangered Species Act, folks that were interested in still continuing to use their recreational dam needed to get permits. And so there was sort of a period of time where both Fish and Wildlife, California Department of Fish and Wildlife, NOAA Fisheries communicated with some of these folks trying to get permits, and it was pretty challenging to get a permit. You had to provide for fish passage, so you essentially had to design and build a ladder at your structure. You had to do a lot of monitoring, and it really was financially prohibitive for everyone. And so all of these recreational flashboard dams are not in use anymore, and this was probably the very last one in 2006. So basically by 2006, no one was using these structures anymore. This slide just shows you a couple of the sort of the structure of them, and I'm going to use these terms. You have the abutments, which are the parts of the structure that are attaching to the riverbank, and usually these structures are built on some kind of a bedrock outcrop. And then what's really important is this term, the spillway. And so the spillway is that center part where the river flows most of the time, and it's where they would have put the boards to dam up the river. And for this study, we're really looking at, well, how do fish get through that spillway? So fish passage, again, super complicated topic. We could do a 2-day seminar, you know, just on fish passage. So this is just the super duper basics. Fish passage for salmon and steelhead, it depends on what species. Steelhead are stronger swimmers than coho, for example. Is it a juvenile, a 6-inch fish, or is it an adult, a 3-foot fish? What's the depth across the feature? We're interested in what is the water velocity, right? How fast is that water moving? The jump height, the pool depth. If you're going to jump, you got to have a pool to jump from. Is it a complex jump? And is there a post-sprint rest spot? And really the way to think about it is these are like the physical capabilities of both individual fish or sort of the population in general to handle challenging conditions. Now, lamprey have a few other considerations because sometimes they use that sucker mouth of theirs to actually grab onto things and kind of inch their way across, and they might do that for these concrete structures. And so for that, it really depends on what's the water velocity, what's the shape, the roughness of the structure, and angles. Are there angles? They dislike right angles, so that's a problem. Okay, so one of the key ideas to really understand the results of this study is to know that fish passage changes with stream flow. And this is also going to come back in the other presentation about the Branson 40 flood control channel. So here's a typical recreational flashboard dam structure in the upper river. You can see there's a jump. We have 2 watershed stewards standing in the spillway, which give you a scale for this next part. So all of the structures I'm going to be talking about are temporal barriers. That's the technical term. And you can remember it by just thinking it's a barrier some of the time. It's not a barrier all of the time, it's a barrier some of the time. And sort of a typical pattern that we see is that at low flows, it's too shallow. So if you're a fish, you need a certain amount of water to physically swim through. Then there's going to be, so this is kind of showing you how the flow looks through the spillway. Then this is important, this is at moderate to high flows, then you have enough depth going through the spillway that you can swim through it, but the water velocity isn't too fast. But then again, at really high flows, it becomes a velocity barrier. Those structures are squeezing the river and pushing it over a concrete structure, and it becomes really fast, and the fish physically can't swim against those high velocities. So this is really important to understand when we look at how we rated these structures for fish passage severity. Okay, this is 4 photos of the same structure, and these are flows measured at Big Trees, which is standardized in the report. But the main thing to look at is start at the upper left and move across, and you can see you have 10 times the amount of flow. Look at how shallow it is across that spillway. And this is one of the main things that was a surprise that we found through this study. Here you have, 80 times the amount of flow. And it's still not meeting depth requirements for fish passage. So that's one of the real key ideas. It takes a surprising amount of water, 300 times as much water, to get an adequate amount of depth over the spillway. So this is sort of unique to these structures and how they're operating in the river. Okay, now I've probably taken too much time. I'll have to speed up now. One of the other key things that we found in this study was that in the late winter and spring, when you have maybe steelhead adults migrating back downstream and juveniles, this is really important, those juveniles moving downstream out to the ocean, there's often really inadequate depth across these structures. And especially during the drought years, we saw some really surprising conditions where there was just, fish were not going to be able to move downstream, especially between storms, or if there were no storms. Okay, so all the structures were rated for passage severity. There's just 4 ratings: none, it's not a passage barrier; low, it may be a temporal barrier; medium, it's a moderate temporal barrier, usually during low flows; and then high, it's a serious temporal barrier during different flows, including low, moderate, and high flows. Okay, so what did we find? So this survey covered 29 miles of the San Lorenzo River, and there were 11 that were no, they were not a passage barrier. 2 that were low, 6 that were medium, and then 18 that had high passage severity. So almost half of the structures included in the survey had high passage severity. So let's take a look at where they're located. For this study, we divided the San Lorenzo up into 4 sections. The lower river is from the mouth up to Zayante Creek, so it's providing passage into those important Branciforte and Zayante subbasins. And in the lower river, there are no medium or high passage severity structures. So that's good news. There's other challenges through the gorge, but there's none of these human-built structures. Then in the middle San Lorenzo River, there's 3 medium and 4 high passage severity structures. And the middle river, again, is really important. It's giving you access up to this, to the majority of the watershed, including the river, the major tributaries off of the middle river, and Bear Creek and Boulder Creek. This is a map from the report just showing how we map the structures and how they're distributed in the middle river. And then as an example, this is one of the most severe passage severity structures in the middle river. This is called Barker's Dam. This is a little bit downstream of Boulder Creek. And this is showing you how it looks in the report with this PAD ID, that passage assessment database. What type is it, the severity. And this one is really severe because it's degraded, and so at very low flows, the river just pipes right underneath the structure, and there's no flow going across the spillway. So there's no passage. And then again, as higher flows, just you can see this is crossing the whole river, and again, just imagine that a lot of the times that whole river has to get squeezed through this spillway. There's also, it's a really complex jump. There's not good jump pool, and it's pretty complex to jump into the spillway. Okay, now we're going to move to the upper San Lorenzo River, which is, above Boulder Creek. And so access to the upper river is, provided to this upper part of the watershed and those smaller tributaries like Kings Creek and Two Bar Creek. And we had 3 medium and 11 high passage severity structures. So twice as many in the upper river as in the middle river. And this is in part because the upper watershed is smaller, and some of the middle river structures were actually damaged over time in big storms. So fewer of the upper river structures were damaged over time. Whoops. Okay, better hurry up. And then this is showing you a map of the upper river. You can see a lot of these structures are clustered in different neighborhoods. This is an example of one of the medium ones, the medium passage severity structures. And again, at low flows, the river just pipes right underneath these kind of floating degraded pieces of concrete. But then once the river is high enough, then there's not an upper limit where it becomes a velocity barrier. So that's why it got a medium. But you can really see these are just old things in the river that are affecting fish passage. Here's another one of the upper river structures that's pretty typical. There's a jump and these really low depths across the spillway. Oops. So in the Waterman Gap, the last 3 miles of the river, we again have 3 additional high passage severity structures. And this is the Highway 9 culvert crossing up in Waterman Gap. And this is one of the most severe barriers on the San Lorenzo River, but it's pretty high up. So it's been the bane of fishery biologists for decades. And it's really challenging because it has this extended apron where again, it can be really hard to get enough flow to have the adequate depth to get over the apron, sprint through the culvert, and then be able to rest upstream. And then this is the Kings Creek Truck Trail Ford, which is within Castle Rock State Park. Okay, so the study included some recommendations, and I'm just going to quickly step through them. One was to identify a program coordinator, and I'm really happy to report that the county is going to continue to be the program coordinator. Sean Abbey, who is going to try to make it here today. There he is! Yay! So Sean Abbey is our new project lead. He's been working on this project for a couple years and has done a great job stepping up and being the program coordinator. Create a technical advisory committee. That's already been completed. It's going to include the county, CDFW, Fisheries, and then these 3 organizations that have a lot of experience designing and implementing fishery restoration projects. You have the RCD, Trout Unlimited, and California Trout. Then the third was send a letter to medium-high passage severity property owners asking for cooperation on removal or modification projects. And we did this too. So Sean organized this. The county sent letters out in December 2023, and we've received multiple positive responses that we were able to pass on to the RCD. And then, of course, move forward with high priority projects. So where are we now? The RCD has already completed several initial site visits with property owners who responded to the county letter and are working with cooperative property owners to move projects forward. So that's really great. We're sort of getting the ball rolling again. The RCD also anticipates having funding to design a few projects starting in the fall of 2024. So we were able to line that up, and that'll really help. State Parks is evaluating removal of the Kings Creek Truck Trail Ford, which is great. And then some of the most exciting news is that Caltrans is in design to replace the Waterman Gap culvert with a bridge. And this is really significant because It also shows this study helped contribute to that because we learned more about that crossing. Jennifer Nelson from Fish and Wildlife and I were part of the state fish pack, and we were able to help them prioritize it. And it was really great because when it came down to deciding what they were going to do to deal with this damaged culvert, this study helped provide the context, right, and the background information for them to make that higher commitment to replace the culvert with a bridge. And this is unique, but yeah. What's really exciting is that not only will it improve fish passage up to these upper 3 miles of steelhead habitat within Castle Rock State Park, but it's also going to be a wildlife corridor where wildlife will be able to go underneath the bridge instead of over Highway 9. And then also it really is going to benefit the community because this was a culvert that was vulnerable to failure, and we all know Highway 9 is a critical evacuation route, and so it will also serve the community to replace it before it fails and have that. So thank you so much, and then this is the end. Sean helped me get the QR code in there for any folks who want to look at it. You can find the report online, and then if you're interested, you can also look at the passage assessment database. Thank you.
Great County of Santa Cruz and all the wonderful people working with them. You do have questions?
Yes, sounds good. Yes.
Where do you want to keep the boundary between the middle and the lower San Lorenzo?
Yes, so we went to just beyond the confluence with Zayante Creek. So the lower river includes the whole Zayante Creek subbasin, and then just beyond that is what we consider the middle river.
Any more questions? Yes.
Jenny? That was one of the projects on my list before I retired. So we'll see if we come back around. I think there's a lot of information that we know already. It's really about just pulling it, sort of like this, just like the hard work of pulling everything together.
Well, Pico, you can do it yourself, right?
Yeah.
Anyone else? Yes.
What's your sense of the social barriers of removal, obviously funding to remove specific barriers to the factor? I'm curious to have some questions. Are you able to, on a broader scale, get some bipartisan infrastructure funding from that bill that deals with aging water infrastructure removal? And for small private hands, is there any state partnership or grant capabilities that they could get money to assist removal?
Well, the good news is that there is money out there for fish passage, and that's why this report is really so important, because it will help bring in grant funding for fish passage and help the organizations know that if they're going to help remove Barker's Dam, we've already done the inventory to say what the potential benefits are going to be. That's another key thing of why we're doing it as a cooperative program, because as soon as you do enforcement, then those property owners aren't eligible to get the grant funding. So we want this to be a cooperative program. We have run into some problems where some of these structures, their great-grandfather built it, and there could be these family emotional attachments to these structures, even though they're not serving any function. And then also just, it is a considerable commitment from a property owner. They have to be willing to go through a process of working with these organizations, providing access. I mean, there's sort of almost like emotional labor on their part to let the project happen. But there is a lot of funding for it, and that's why we feel really optimistic, and we feel optimistic about working with this first batch of cooperative property owners and getting something done. Really briefly, one of the things when you're working on improving fish passage, there's often this model of you work downstream to upstream, because you're usually dealing with more severe barriers. But in this case, they're all temporal barriers, and so any removal will assist with passage both upstream and downstream.
Well, that's amazing. Oh, yes, one more.
Well, you said that some people have responded to, like, what percentage of people you mail?
It wasn't a lot from the private property owners, but we have a number of agencies. You know, we've gotten positive, the county, state parks, Caltrans. We have the Boulder Creek Recreation District is going to reconsider. So we're hoping to get those involved. We're hoping that by doing maybe some pilot projects, we can help sort of build interest, like, okay, they survived the process of having this done. Okay, we're willing to do it now too.
All right, well,
All right.
I love coming to these things because I learn a lot. And Kristen, thank you very
Yes.
much. And good luck with your retirement.
Thanks.